Hi. I have shared the course plan. It is in the web. Let me share it. So you can see the screen now. Okay. Here you can see the course plan. Right. I will share the course plan with you. This is the course plan. We had the first lecture on 28th. So today we have to do the protocol standards, these things. Then this is a tentative plan actually. So I am expecting to have here assignment 1, test 1, 11th March. So that will be MCQ test. To get ready for the MCQ test, so here 3 assignments. This is the first assignment. To get ready for the MCQ test, I will give some tutorials. So if you answer those questions in the tutorial, you can easily answer to the MCQ questions. So you have the test 2. So that also you have MCQ test as well as it's a group assignment. So by 8th April, then you have the interviews for the group wise for your assignment. Then you have the test 3 is mainly from the mobile communication. Okay. Any question? Right. Then I'll go to the course plan again. So this is the course plan. So this is Feruzan's book. I have uploaded that book. You can download this book also. And starting from this book today, protocols standards, I'll be using from this book. So chapter 1 and 2 is about the protocol standards and the network models. Right. Please read these 2 chapters. Chapter 1 is about introduction. You should have the idea about the data communication. So data communication networking. And what is data communication data? You have a sender and you have to have a receiver. To connect them, you have to have a medium. This medium can be free space or copper or fiber. Then protocol. So we are talking about the protocols, IP protocol, TCP protocol, like that. What is a protocol? The protocol is a set of rules that govern data communication. It represents an agreement between the communicating devices. So this is the some kind of rules. That means, okay, I will send. The first one is I am sending request to you. Then you acknowledge to me. Then I will send data. Then you acknowledge me. Something like that. Some set of rules are there. These are called the protocols. Then the data communication. You should know what is simplex, what is half duplex, and what is full duplex. Simplex is you can send only one direction. Send it to one direction. So to send one direction, any signal, you need two wires. So therefore, in the simplex communication, you have two wires to communicate sender and the receiver. Then half duplex. Half duplex means it is can communicate to both directions, but one direction at a time, not simultaneous. So therefore, these two wires are sufficient for the half duplex. Two wires, you know, the two wires are required to send signal to one direction. So these two wires can be used for send to this direction or this direction. Only one direction at a time. In the full duplex means you have four wires. That means simultaneously you can send signals or the data to both directions simultaneously. Okay, so that is the meaning of simplex, half duplex, and the full duplex. The networking, so different network topologies, mesh, star, bus, ring are there. Everybody knows those things, but you can refresh those things by reading this chapter. The networking models, different networking models are there. So protocols and standards. So I mentioned about the protocols. It is in detail here. What is protocol? In the standards. Why we need standards? So standards are very important in the world now. When you are going to buy a shirt, you know what are the standards there. We can say the 16, 16 and a half, like that. So when you want to buy a tire to your vehicle, then you know the tire sizes. So these are standards, worldwide standards. Similarly, in the data communication, you have the standards. So standards are very important. There are standards organizations. Organization, they define the standards. So one organization is the International Organization for Standardization, ISO, right? And other one is the ITU, International Telecommunication Union, ITU, right? Then American Standard Institute, right? ANSI. They are the Institution of Electrical and Electronic Engineers, IEEE. So IEEE, then the EIA, ISO, ITUT, ANSI, IEEE, EIA, these are standard bodies. In addition to that standard bodies, you have the forums. Then you have the regulatory agencies. So for instance, in Sri Lanka, you have the Telecommunication Regulation Commission Sri Lanka, TRCSA. So there are so many standard bodies. So these standard bodies are for different purposes. Then you have the internet standards. In the internet standards, these standards are called the RFCs. Internet standards are called the RFCs, request for comments. Although it says the request for comments, it is their standards. Then the network models. So that is protocols and standards I mentioned. There you can see what are the standards, and these organizations are providing which standard. For instance, the IEEE is an organization, they are providing the standard for computer networks and so many other things. So for wireless communication, normally we use the IEEE standards. You might heard about the 802.11 standards like that. Now in the networking, you have network layered architecture. Layered architecture means we have divided this to layers. So layers mean there are no physical layers. This is a concept. Even when you go to airport, there are some layers are there. First layer is the security layer. You access from there. Then next you will go to the ticketing. Get your ticket. That is the second layer. Then you go to the immigration. That's your third layer. Like that. So this is some kind of concept. Now in the ISO OSI model is a layered architecture. So there are 7 layers are there. Okay. So these 7 layers everybody knows, I think: application, presentation, session, transport, network, data link, and physical layer. Right? When it is starting from the one layer, the layer can put the header there. So this is the data. When it is come to the next layer, this data and header is the data for this is called this is the data part. So that also called the payload. Payload is the header and data. And when it is come to this one, next layer, this payload and header will be the payload of the next layer. Then payload and header will be the payload of the next layer. Like that, it is going up to the physical layer. Then physical layer is it's a signal. So you will physical layer actually it is converted to raw bits, 0, 1, 0, like that. These raw bits are converted to signal at the physical layer. So let us see the function of each layer and what is the physical layer is doing. Physical layer is data is coming from the data link layer. So they will put it to the raw bits. They put it to the raw bits. Then the raw bits are converted to signals. So these raw bits are in the some memory area, in the memory chip. So you convert this one to signals. It can be electrical signal, optical signal, or wireless signal. Then it is going through the transmission media. So these are the functions of the physical layer. You can go through that one. Physical characteristics of the interfaces and medium. That means the physical layer defines the what is the interface is using, and in that interface how many pins are there. That kind of details are there. And the represent the bits, the zeros and ones bits, and it is a 5 volt or 0 volt, that kind of things. Then the data rate, physical topology, transmission mode. I mentioned about the transmission mode, simplex, half duplex, full duplex. In the data link layer, it's a data layer transfer of the physical layer raw transmission facility that is converted to the raw bits, ones and zeros. So it is coming, the data is coming from the network layer. So it is putting header and trailer. Other layers are putting only the header. In this layer, they are putting header and trailer. The framing part is doing, this is called a frame. In the data link layer, we call this group of bits is called frame, not packet. Okay. So remember that one. And we are doing the framing. And there you have the physical addressing. The data link layer also uses some kind of addressing. That address is called the physical addressing. Why it is called the physical addressing? That address is physically there. Normally it is in the network interface card. So this one type of physical address is the MAC address. So we are using the MAC address as the physical address in the data link layer. Then it is doing the flow control, error control, and access control. And can somebody say what is error control? What is error control? Okay, I ask from one of you. Asini Ranatunga, can you tell me what is error control?
Actually, I don't have much idea on it.
Oh yeah, okay, no problem. So I know you study these things, everybody studies these things, you may forget those things. That's why I'm refreshing those things. So I will discuss about the error control later. Then the flow control, error control, access control. Okay, I will use the sideboard for this one. What is error control? I will explain it now. So we can transmit data from one place to another place. Okay, from here to here. So this is our transmission media. It is going from here to here. So normally we are sending digital signals. The digital signals, it is going as ones and zeros. I'll discuss about digital signal later. So this is 1 and this is 0. So this is 1 and this is 0. When it is going through the transmission media, this 1 can become 0. I will explain that how it is happening there. So you transmit it as a 1, so he will receive it as 0. If this 1 becomes 0 at the time of it is receiving, then we call it is an error. So you transmit the 1, at the receive end, it is coming as 0. Right? How it can be happen? We have to see why 1 will become 0 when it is coming to here. So it is called an error. Oh, suppose you are sending a digital signal, it says this is 1,000 rupees. You encoded in some manner, sending it there. Because of this error, there can be error. 1 becomes 0, this 1,000 can become 100. Right? So then it's a big problem, and we have to have some solution for that one. So what is the solution we can give for this one, for errors? Can somebody say, if there is error, what is the solution we can give for that one, for the errors? Chatura, if there is an error, I can't hear you. If there is error, what is the solution we can give?
First, we want to check what is the error. Is a physical error or software?
Okay. Vimal Shah. What is an error, Vimal Shah?
I don't have much ideas.
Okay. Now in the assignment 1, I asked these questions. So error means that the 1 can become 0 and anybody can say, what is the solution we can give for these errors?
We must have a device to convert the error into right protocol.
What do you mean by that?
We have to have a device that finds the error and provides a solution for it.
Not really. If there is error, we have to correct the error. That is the solution. No?
Putting a repeater?
No, repeater will not be the solution for this. It's very good. You give the answers like that, then I can correct, right? Rather than just listening to me or some students may just
You
log in and they
using
may not be here.
acknowledgement techniques?
Yes.
Using acknowledgement techniques, and sometimes we can encode 1 and 0s to check the flow correction. Include if it is a packet, we can include 1 or 0, some kind of pattern to verify whether that data is correct or not.
Yeah, some extent your answer is correct. Any other? Yeah. Yes.
Wireless Wi-Fi routers connectivity.
No, my simple question is, if there is error, what we have to do is that we have to correct the error. How we can correct the error?
Physical layer or presentation layer connectivity.
So we can actually count the ones and zeros of and identify whether there are any missing ones or zeros and correcting that bits again.
Okay. Have you studied about the error correction methods?
I never heard of them before.
Okay, this is very important for wireless communication also. We have the error correction we will study, right? Error correction methods. So when there is error, we have to correct it. Okay, we are sending the data from here and it is received here. We have to correct this error. There is error. One method is if there is an error, we will inform to the sender there is an error. Then he will send that data again, that frame again, right? So that is one method. Then what he has to do is he has to keep this data here temporarily somewhere here until the confirmation is coming from here. So I am not teaching any technical things here. These are just to simple common sense you can understand, right? So you have to keep the data here until you get the acknowledgement from here. So temporarily you store the data here, right? Do you know this temporary memory? Anybody can say what is this name for that? This kind of memory is called what?
Violate memory.
This is called a buffer. This is called buffer memory, right? So you are sending a frame from here to here, right? Now, then he should identify whether this error-free frame or error-free, whether there are any errors are there. For that one, to find out whether there is an error or not, what is the method you can use? What is called it actually? Anybody can say?
Buffer reader.
No, it's called the error detection. Error detection. If there is error, you have to detect the error first. Right? Have you heard this word, error detection? Then you have to study about the error detection methods. Right? Error detection methods. What are the methods we can use the error detection? Right? Can somebody say any error detection method, you know?
Acknowledgement.
Not acknowledgement, error detection methods. If there is error, you have to detect it. Right? Have you heard about the parity bits? Parity? You have to include parity bits, additional bits.
Cyclic
Right?
redundancy. Cyclic redundancy.
Yeah, one method is the parity bit. From that one, you can detect the error. Another method is the cyclic redundancy check.
CRC.
CRC bits. You can include the CRC bits. There are many methods to this error detection. Right?
Hamming code, sir. Hamming code.
Yeah, Hamming code like that. Different methods. I'm sure you studied about the error detection methods. So this is for that. There can be errors. This error can be detected. Right? For that, detect the errors. There are error detection methods. So these things are very important for any kind of area. Even if you are a software engineer developing the software, you should know this, right? So I am teaching you the very basic thing because that is very important to understand the rest of the things, right? Rather than you are getting a good grade, you have to get a good grade for the subject, but with knowledge. So that will be very useful to you. So normally what happened in our country is people are getting the good certificates, but there is no knowledge. That's why our country is in this situation. Just like the you must heard about the Adi Haddenage Kandahali, right? Nobody put price to the Kandahali. Right? Likewise, everybody has very big qualifications, but they don't have knowledge. So we are talking about the O level, A level, different qualification, but the knowledge is the problem and also applicability. How many people can apply this knowledge? So from this subject, I will try to help you to some extent to have this characteristic, think, how to think and understand, right? Okay. Another person give the another method for the error checking is the checksum. That also correct. Checksum bits. Very good, right? Now you may remember that, okay, we studied about these things, right? So practically these things are we are using now, error detection methods. So therefore in this subject, so we have to have the idea about the error detection methods, and the assignment questions are coming from this area also. And the Feruzan book, there is a complete chapter for the error detection, right? Any question from the error detection?
Sir, did you give an assignment? I came later on, so I missed it.
Yes, we have 3 assignments and the 3 exams. 3
When
MCQs.
is the first exam deadline?
Okay, you better ask from somebody who attended the class on time, right?
Okay, okay.
Right. Okay. Punctuality is very important. So normally what happens in our country is no punctuator. Those who are coming on time has to wait until others are coming. Then we are wasting those who came on time, right? So I am very punctual. I start the class on time. So normally I give all the information required for you in advance. So therefore, please attend the class on time, right? Right, error detection. Now what is error and what is error detection, and what are the error detection methods, right? So when you send the data from this sender to here, and you want to detect the errors here, right? Right. So what you do is you are sending a frame with one of these method, parity bits, ERC bits, or checksum bits, or for do these things, you have to do some coding. Different codings can be used. I'm sure you studied about the code. There's somebody say about the Hamming codes, right? So then data you are sending frame with the error detection method, particular error detection method. For that one, you have to put additional bits to your frame. Then it is coming to here, and you will keep a copy of your frame here at the transmit end in the buffer memory. Then receive that one. Then he check whether there are errors. If there is no error, or if there is error, he has to send the acknowledgement to the sender. Okay? Please listen very carefully. This is very interesting and very logical. And this is sending the acknowledgement to the sender, right? Then that is a feedback getting from the sender. Then if he is getting a positive acknowledgement, that is called, okay, he received the data without any error. If we get the negative acknowledgement, what he will do? What is the sender is doing when it is a negative acknowledgement? Can somebody say?
Send it again.
Send it again, correct. Yeah. Because he kept a copy of this one, no? Here in the buffer memory. If we get a positive acknowledgement, he will delete that frame from this temporary memory, from the buffer, because buffer is a very limited memory area. So you will delete it. If you get the negative acknowledgement, you send it again. Then you are getting the acknowledgement again. If it is positive acknowledgement for that particular frame, then you will delete it, right? Is it clear? Right? So that is the once you detect the error, then you are sending to inform to the sender there are errors, then he will resend the frame, then he get the corrected frame. Now you have corrected that.
Excuse
So,
me,
yes,
is this applying to TCP and UDP both?
it can be applied to any layer,
Uh,
right? This is a common concept.
mhm.
But normally this is applying in the data link layer and the transport layer.
No,
Right?
I mean TCP and UDP protocols.
Yes, TCP in the transport layer, UDP
yeah.
does not have, TCP have, right?
Mhm.
That's why I call the TCP is a reliable protocol, right? Okay, good question. Yeah, you can ask questions like that. You will recall what you studied so far, actually, right? Now you understand what is error. Now you know error detection methods. Now you know error correction methods, right? I think that we already studied these things, but today maybe you understand properly that. So any question from that one?
Sir, could you please tell us about the cyclic redundancy test? A bit more detail.
Yeah, thing is that I have 40 lectures now. So you can see these things in the Perusan's book. Yeah, that particular chapter, error detection and correction. All the details are there, right? Okay. Because the cyclic redundancy itself takes several hours to explain. For this subject, if you understand what is CRC, that is enough. There is something called CRC to detect the errors, right? So here, that one you understand now. Now suppose you are sending a one frame. You keep a copy of this one here. And also buffer in the buffer memory in the receive end also. Small memory here in the receive end also. Receive end. We have another buffer memory here. That also buffer. So when you send a frame from here, say F1 frame, you are sending to here, and he will put this F1 frame to here. Then another frame can come, say the F2 frame. He put the F2 also here. So he will take the F1 to check whether there is error. Until then, F2 is in the buffer memory. Similarly, it can be F3, F4, all these things can come. Depending on the processing power of this receiver, it can decide how much time taken to detect the errors. So they have to process that frame. So therefore, there is a temporal memory. So he will take the first frame, check that one. If it's okay, it is in the other side. Then he take the second frame. Until then, many frames can come to here. Then he will keep it in a here, in this buffer memory. Now, suppose this buffer memory can have only 10 frames. 10 frames. Already 10 frames are now here. If the 11th frame is coming to here, what will happen? There is no space here to keep that frame. Can somebody say what will happen?
We can delete the previous frame.
No, there is no place to keep that frame. Therefore, he cannot accept it. Then overflow the frame. Just like the overflow in the water, it's overflow. That is called buffer overflow. Right? Then this process is called the flowing. Flow. Data is flowing from one place to other place. Data flow is there. Right? Then if this buffer, the receiver's buffer is getting full, he should inform to the sender, my buffer is getting full, don't send any more frames. Understand? So that some kind of communication should be there between the sender and the receiver. So that is called flow control. That is called flow control. Have you heard this word before? Flow control. Anybody heard it? Right. Okay. Then you know what is the idea about what is flow control, what is error detection, what is error correction. Now this error correction, the method I explained is called backward error correction. Backward error correction because so you have, if there is an error, you have to get from the sender that the same frame from there. That is called backward error correction. But there are methods without asking the sender, the receiver, the receiving end can detect and correct the error inside. It can do the detect the error and correct the error. Right? That is called forward error correction. Forward error correction. Or it's called the FEC. Right? Have you heard this word, anybody? Forward error correction? Gayan,
Yes.
you heard about forward error correction, no?
Yeah.
Right? So FEC,
Sir, the buffer is in the RAM, right? RAM, random access memory.
yeah, buffer is some kind of temporary memory.
It's like a chip, right? A little chip.
Yeah, this memory management is another thing. So same chip, memory chip, you can use for part, one part you can use the buffer memory, some part can be used the user memory, something like that. So that is you have a memory chip, yes, that part of that memory is used for that, yes. Okay. Now we have this book here. I'll share the book again. And this book, you can see this chapter 10. Can you see this? Chapter 10, error detection and error control. Right? What I explained you is already there, right? So I will go to that one, chapter 10. This is chapter 9. Now it must be very interesting to you. Error detection and error correction, right? And the types of errors, single bit error, burst error, and the detection versus correction, forward error correction versus retransmission, then the coding, you have the block coding and the convolution coding. Then the modulo arithmetic, you should know the modulo 2 arithmetic, modulo Normally they use the modulo 2 arithmetic. Then the block coding for data words, code words. But all these things you don't want for this subject, for this information. Then there are correction, how to correct the errors. Then the Hamming distance, minimum Hamming distance. These are very interesting actually. This is mathematical also. Then the linear block codes, simple parity check code. Then the cyclic codes, cyclic redundancy check, CRC. Right. Then the other cyclic codes, checksum. That is about the error detection and error correction. Then the data link layer level control, that is not only for the data link layer level, any layer it is correct. In the data framing is there in the data link layer. You can see this data link layer, then the flow and error control. How the flow control is doing. I explain to you what is the flow control, then the error control. So the automatic repeat request, that is the backward error control method, ARQ. And then you have the different protocols. Stop and wait, go back and go back and selective repeat ARQ. Then the noiseless channels. Okay. So many things are there. So what you have to understand here is the error control and the flow control. So I'll go to the data link layer again, the OSI 7 layers.
So actually, I have a question.
Yes.
Who actually decides which method should we use to correct the errors? I mean, whether we are using forward error correction or backward error correction. Who decides that actually?
It depends on the standards. For instance, say the 802.11n standard, what is the error correction method going to do? So they can use the backward error correction as well as the forward error correction. Sometimes the both are used. When the errors are less, they are using the forward error correction. When the errors are high, they use the backward error correction. That kind of error correction is called the hybrid error corrections. So likewise, the standards and the protocols are defined all these things. Okay.
So in the modern practice, what kind of error correction method we are using? I mean, forward or the backward one?
It depends on the applications.
Application, yeah. Okay.
Because in the forward error correction, you need more bits, additional bits, right? So therefore, very critical applications only, you use the forward error correction.
Yeah, thanks.
Okay. For instance, the defense applications, like that kind of thing.
Yeah.
Okay.
Thanks.
Okay. Any question like that? I would like to hear the questions. Then only I can see you are engaged. Right? So I have explained because all these things are required for the wireless communication. And I was here, data link layer. I explained about the framing, physical addressing. Can I explain the flow control and the error control? Right? Then another one is the access control and also the physical addressing. Now, when you take a network, any network, any network, right? I'll take a network like this. You can have the computers here. You can have the computers here. So you can connect these computers in a different manner, right? One method is you can have one wire here and connect them to this wire. This is one kind of topology of the networking. What is called this topology?
Bus topology.
Bus topology. Bus
This is bus
topology.
topology, right? Then you know the star topology, mesh topology. So like that, different topology, right? So in the, consider this bus topology. Here, this is one line, it's a one copper line. So everybody is sharing this copper line. Now, suppose this is the computer A, this is B, this is C, and this is D, right? This is, now computer is sending a signal. In the copper line, the signal is electrical current. He is sending electrical current from here to here. Electrical current. Right? Then it is going through here. Suppose this computer also sending a current here or signal here. Then what will happen? These two can be mixed up. These two can be mixed up. Then we cannot read these bits because these are two mixed up. This kind of thing is called a collision. This is called collision, right? So it is just like a one, this is a single lane. Suppose these A, B, C, D are houses. Only one vehicle can go through this road. So suppose the house A is putting his vehicle, his car to this road. B also putting car to here, right? Then these two, there is a possibility of collision of these two. Suppose they are going the opposite side, definitely it will collide. Then what is the solution for this one in the practical world? The house A person come to the road and see whether any vehicle is there. Right? If there is no vehicle, he will use this road for his vehicle. Right? So before he's accessing to this network, he will check whether anything is there, any vehicle is there. So that is called access control. Access control. Right? So there should be some method to do the access control. Right? So therefore, in the data link layer, you are doing the access control also. Can somebody say what method of the access control in the Ethernet networks? Access control? Yeah. Anybody can say? Have you heard the CDMA, the CSMA CD?
Half duplex.
No, access control method. CS. Okay, there is a separate chapter for this one. I will share that chapter with you. The data link layer, this is chapter. I will go to that chapter. You can see here. Tail lighting control, multiple access. Chapter 12 is multiple access. So first I will go to the chapter 11, that is the data link control. That is 307, chapter 11. Okay, chapter 12 is the multiple access. In this chapter, we discuss data link control mechanism which provide the reliable communication. So here, in the data link layer, we divided two parts, data link control and the multiple access control method. Right? So multiple access, you can use these technologies. There are three: random access protocols, control access protocols, and channelization protocols. So we can use the CSMA CD, CSMA CA, CSMA Aloha. Can somebody say what is CSMA? That is called carrier sense multiple access. CD means the collision detection. In the Ethernet networks, you are using the CSMA CD. And the wireless networks, you are using the CSMA CA. Carrier sense multiple access collision avoidance. Right? Then control access protocols is a special application. Then the channelization protocols, we have the FDMA, TDMA, CDMA. We will discuss about these things. Frequency division multiple access, time division multiple access, and the code division multiple access. Right? So this is the access control technology. So this is using in the data link layer. Access control is used in the data link layer. Okay? So the data link layer is doing the access control part. Right? Okay. And I'll go to the sideboard again. Now this is a bus network. So they have a wire here, one wire, it's a bus, it's called a bus. So these computers are connected to here. Now the network is wired network, wired bus network. And the access control path is the CSMA CD. CSMA CD means before he is accessing, he will check whether there is a carrier. That is called the carrier sense. And by that way, multiple people can access to here, multiple devices can access to, that is multiple access, CSMA CD. After he is accessing to here, he will check after some time whether any collision is there. There are methods to do that done. So then if it is no collision, he will not do anything. If there is collision, he will retransmit. That is called the collision detection, right? So that is the access control method used here. And here the network technology is the bus topology. The topology is the bus topology. If it is bus topology, and the access control is CSMA CD, then this is called Ethernet. This is called Ethernet. This together, this one is called the Ethernet. Right? So this is doing in the data link layer. So is it clear now what is the access control? So data link layer is doing the access control part. So wireless communication, access control, we will discuss separately. Right? Any question from this one?
So the Ethernet can be applied for other topologies.
What?
Ethernet only applies for bus topology, right?
Yes. Bus topology, no, Ethernet means bus topology plus access control is CSMA CD. It is together, it's called Ethernet. You cannot use this Ethernet word for anywhere else. Right?
Not for other topologies as well, right?
No, topology is something, access control is something.
Okay.
Right? So when the bus topology plus CSMA CD is called Ethernet.
So we can use the access control method for star topology.
Yeah. Yeah, this you saw this. It is using some kind of token there. That is called token ring. Token. Even the bus topology can use the token. Different methods are there. Yes.
For star topology and other topologies.
Yeah, the star topology, bus topology. In the bus topology also can use the token, and the ring one also, ring network also can use the token.
Tokens. Thanks.
So, so it must mean that every topology plus CSMA CD is Ethernet, right? Every topology.
No. Bus topology plus the access control CSMA CD is called Ethernet.
Oh, okay. Must remember that.
Yeah. Okay. Right. Now the data link layer level, you have studied so many new things. Now here you can see the many computers are connected to this bus network. Then how do you identify these computers? You need some kind of identification, because when he's sending a frame, he has to mention what is the destination address. Right? So what is the address method we are using here?
IP address.
So in the data link layer level, you are not using the IP address. IP address is using the network.
Address,
Hmm?
MAC address, MAC address.
Yeah, MAC address. Correct. It's the MAC address. The address we are using is your MAC address. How many bits are there in the MAC address?
16 bits.
No.
Uh,
32.
32 is IP address.
64.
64.
48.
Any address with 64.
64.
Hmm?
No, 1 to 8. 1 to 8.
1 to 8 is IP version 6.
48, I think.
16.
Can say 16, 32, 48, 64, 96, 1 to 18, one of these things. No? It is 48 bits. right? So in the data link layer level, we are using 48 bits address that is called MAC address, right? Actually, when you talk about the local area networks, this data link layer is divided to two parts, two layers. Okay. One layer is called the MAC layer, media access control layer. Another one is called the logical link control layer, LLC layer. So in the local area networks, data link layer has two parts called the LLC layer and the MAC layer. So MAC layer is the mainly for the media access control part, right? The address we are using here is called the MAC address, right? Shangavi gave the correct answer here, 48 bits for the MAC address, right? Any question up to here?
So I have a small doubt.
Yes.
When we downloading some file from the internet by using such as some kind of software like internet downloader, that download the same file by separating multiple part at the same time. What kind of method is used to their download?
Multiple parts.
That means same time or multiple parts, same file separated into multiple parts, and that those multiple parts are downloaded at the same time.
Yes. So that is one is the application. Application should have that control. Normally that these things are controlled by the session layer. So one part is coming as one session, right? At the receive end, they know how to connect these things, right? Okay, have you got the answer to your question?
Okay, sir.
Somebody asked, do we have lecture slides according to this module? Why you want to lecture slides? These are lecture slides actually.
So these things are very new. It's hard. It's kind of hard to memorize.
Yeah, that's why I'm giving the reference, you know. You don't want to remember anything,
Yeah.
everything.
You are teaching good, but I want to like memorize everything before the exam.
Don't memorize these things. This is the master degree. What is the pre-qualification to do a master degree? You have to have a bachelor degree.
Bachelor's.
That foundation should be there to understand these things. If you have done a good bachelor degree, you must have done all these things, but not too in depth. What I am doing is I am refreshing these things. So this is wireless network technology subject. This is not actually, so I have to just touch these things to understand your wireless network technology. Right?
I understand the various type of topologies, networking side.
Yeah, I don't want those things actually for this subject, but my part is the wireless network technologies. I am coming to that one, right? But understand that one you need these things. But you don't want to remember all these things. You don't want to see what is how the cyclic redundancy check is doing, right? That is up to you to further study that one. But you should know there is something called error detection is there. To do that one, you need the CRC bits. One method is CRC. That kind of conceptually you understand those. Okay. So you can refer that book. I always give the book I am referring, so that from that you can get it is up to you to how much depth you study it. Right? But I don't have time to teach everything, and I am not going to ask from each and every part of this questions. Right? Is it clear? Any question? Right. Then I will come to still I am in the data link layer here. So slides are there to just to give the highlight what we are teaching, right? So I am doing the same thing in a different way, right? I am using the whiteboard. I am using the book, and you know where I am referring it, right? So you don't know to understand whole book. This one, it's a complete module, maybe the several semesters. Okay, now we are in the data link layer. What are the data link layers doing? Now you understand what is the meaning of these things. Data link layer is doing the
Access control.
framing, physical addressing, flow control. Now you know what is flow control, error control, and access control. Okay, any question from this one about the data link layer? These are the things I am interested in, not this all theories of these things, right? I could say there is physical addressing, flow control, error control, access control. So you may remember these things, then you can answer the question I asked, but without any knowledge, right? Are you agree with me?
Yes, agree.
Right, that is about the data link layer. Then I am going to the network layer. The difference between the data link layer and the network layer, you have to understand. Can somebody say what is the difference between data link layer and the network layer? Anybody can say?
Network layer connects to many locations rather than to one location.
Right. Data link layer.
Data link layer comprise only for one organization in one building.
Okay. To some extent, you are correct.
In data link layer, we are sending frames, but in network layer, we are sending packets.
Yeah, that also correct. Yeah, what you said is correct, but no, that is not the question I asked. Difference between the network layer and the data link layer.
Network layer is a connect the other nodes.
Okay, I will explain this, and I'm sure you don't have a clear idea about that one.
Data link layer separate the sending sources into several packets according to the order, and in network layer we link that to the medium which we are going to transmit the data.
Okay, but not the correct answer. Only thing is the students do not understand the concepts. Yeah, using many words, packets and frames, different things, but we have to understand the concept. Now see I draw a local area network here now. Local area network, okay, one computer, two computer, and another computer here. So this is here, bus. Okay, this is one local area network, LAN 1, I say. And you have another network here, say, another local area network.
Wide area.
is another local area network. This is the LAN 2. Suppose you have another local area network somewhere here. This is the LAN 3. Now suppose this is Colombo. This is Candy. This is Gold. Now these are local area network, right? Now I want to connect this local area network. How you can connect? How
Using
we
router.
can,
Using router you can connect.
yeah, we need a router. Okay? I put a router here. I put a router here. And I put a router here. Right? Now you want to connect them. How do you connect them?
By IP addresses?
Now I am asking how you are in Colombo, Candy, Gold. I want to connect these three routers. I am asking simple question. Don't, I am not asking
Using a
anything.
medium,
From a
Hmm?
network.
using a transmission medium.
Yes, you need a transmission media to connect. Then how do you connect practically?
Through internet.
Using a server?
Using a server, how you can connect?
Transportation layer. Transportation layer.
Through
Transportation
internet.
layer, how do you connect? Now you are
By
recruited to a
networking.
company and you are asked to connect these three networks.
By networking.
Network wires. Using wires.
Hmm?
We need a software to connect the network.
How do you connect with the software?
By networking.
What do you mean by networking?
Through internet.
We need network drivers.
Yeah. One answer is correct. Okay. Through internet you can connect it. Right? Or you can get the connectivity from the service provider. Right? So normally you get the connectivity from the service provider. Who are the service providers? Sri Lanka Telecom, Dialog, Mobitel. So you can ask from the, okay, we want to connect our three networks. Give a solution to us. They will connect you. They have different technology for that. One is the lease lines. It's a separate line. Other one is the something called the MPLS, one technology. Likewise, they will give the connectivity to you. You don't have to worry about that. Or you can get the internet connectivity from them, and through internet also you can connect them. But only thing is the internet is very unsecure network. Security problem is there. So can you make this connectivity through internet with security?
We provide a firewall.
So firewall is a device. From a firewall you can do the security.
Using a secure
gateways.
protocol. Using a secure protocols.
Through VPN.
Yes, that is correct. Through a virtual private network, you can give the security, VPN, right? Okay. Now you have to connect this one then. So you can maybe you can get the internet connectivity or one of the methods you connect them. If it is through the internet, you can have the VPN connectivity from here. If it is the service provider, they will put one of the technologies and give the connectivity to you. So once you connect this one, it is called a wide area network. These are wide area links. The connectivity from one station to another station is called wide area link. WAN link is there. Right? So this is the way you are connecting your network. Now I started this one with the data link. So what is the link? So link is the one from here to this router. So this is a one link. Right? This is a So this is a one link from here to here, right? Then this is another link. And this is another link. So data link is up to the router. Right? And the data link layer is looking after one link only. So within the data link to communicate, you need the data link layer, and the address we are using is the MAC address. And between two stations, to connect, you cannot from the data link layer, you have to connect to the network layer. Right? So network layer is there to station connection with any two stations. Either it is within the LAN or within the wide area network. Right? So when you go to the network layer, that is in the network layer, the addressing is the logical addressing, you need the routing. So their addressing is a different one. That addressing is the layer 3 addressing. Normally this addressing is the IP address. Normally this addressing is IP address. Okay. And you need some kind of routing, not like the data link layer, because when you come to the router, you have to decide to which direction you are going, your packet. Right? So when a packet comes to here, when a packet comes to the router, it should decide whether it is going to this direction or whether it is going to this direction. So therefore, that decision should be taken at the router. That is called the routing. Right? So it is doing the routing also in the data link layer. So addressing we are using in the network layer is the IP addressing. So when you take a computer, now consider this computer, what is the address this computer can use? MAC address or IP address?
IP address.
Yeah, this has the both addresses. When it is communicating in the local area network, it uses the MAC address, and you need the communicating between two stations, you need the IP addresses. So the IP address can be used within the LAN also, but the data link layer level, when you are sending the frames, it is MAC address. Then if you want to go to one station to another station, you need the IP address. So normally any device has both addresses, MAC address as well as the IP address. Right? Okay, any question?
So I have not a group for this module group assignment.
I don't answer to your question. It is not relevant to this. Right?
I have not a group for this.
I have not formed groups.
Yeah.
Then why are you asking that question?
I have not a group for this module group assignments.
I haven't given any group assignment.
I have not a group for this module group assignments.
Okay. Right. Now look at here. These are the links. You can see link, and so when it is going to source to destination here, you have in the network layer. Then the transport layer. What is the difference between the network layer and the transport layer? Network layer and transport layer.
Transport layer provides all the mechanism rather than that on the other layer.
Now suppose this is the Candy, you have a web server. Right? The same computer as the FTP also. It is a FTP server also, right? Now suppose the Colombo, this computer is accessing to this Candy web server. It is accessing to the Candy web server. The same computer is accessing to the same computer FTP server also. Now here the destination IP address is same, but this processor or the program is different. Then you have to give some identification for this program. This identification is given from the transport layer. So transport layer gives some identification this way. So it is the transport layer address. Normally it is called port address. It is called port address, right? So here in the transport layer, you can see service point addressing, segmentation assembly, connection control, flow control, error control. So the transport layer is giving address to one application. So you can have different applications, right? So in addition to that, when the data is coming from the upper layer, it is divided to small parts. It can be divided into small parts and centered. And that is called the segmentation, and the receiving they are combined these two. That is called the reassembly. Then service point addressing is the address you are going to the program, right? That also called the port address, right? So what is the port address of the web server? Port address of the web server? Yeah, it is 80, right? If it is HTTPS, yeah, it's the 441. 441, right? So the different servers, you have the different port addresses. So in the transport layer, you can have these things also, flow control, error control, but it depends. When you use the TCP protocol, you have the flow control, error control, but UDP protocol you don't have, but that optionally it is there, right? Then you have the session layer. The session layer, you are doing the dialog control and the synchronization. Synchronization means that you can send a large file, as somebody asked. So when you are sending the large file, you can send the, say, 100 pages at a time. Suppose we have 2000 pages, 100 pages at a time, and then you can put some mark there. So if there is error in one page, so you have to retransmit the same page only, not the whole file, right? So that part is maintained by the session layer. In the presentation layer, so they are doing the encryption, compression, those things are doing by the session layer. The application layer is the one, we are using all these for different applications, that is the application layer, right? When you go to the TCP IP protocol, it is different. They have combined these three layers together. Application, presentation, and session together and say the application layer. And they have the different protocols, SMTP, FTP, HTTP, like that for the application layer. Right? In the transport layer, you are having mainly two protocols, TCP and UDP. And the network layer, you have mainly having the IP layer protocol, but along with that one, ICMP, Internet Control Management Protocol, and in IGMP, Internet Group Management Protocol, and also the ARP. What is ARP? Address resolution protocol, and the reverse address resolution protocol also there. Okay. In the data link layer, earlier in the TCP IP data link and the physical layer together, now in the modern one, new ones, they have 2 layers. Right? Then I have a video of this one. I will now play that video. Okay.
We've previously talked about the OSI model, but did you know that it's not the only model out there? Its competition is the TCP IP model.
Can you hear this? I posted now.
Yes, sir. Yes.
In this video, we're going to learn about this model and see its perspective on the network. If you haven't seen the OSI video yet, now is the time to go back and check it out. As we discussed there, a model is a set of layers that describe how network hardware and software work together. The goal behind the OSI model was to allow different protocols and vendors to work together. The idea was to build protocols directly based on this model, but we don't see a lot of them today. The main reason is that the protocols from the competition, the TCP IP model, gained more popularity. The TCP IP framework was originally developed by the US Department of Defense. Later, various universities and other parties got involved. This led to rapid development, which is probably why it has been more successful than OSI in a practical sense. Now we have protocols like TCP, UDP and IP, which align directly to this framework. Another reason this framework has been so successful is that it's willing to use existing protocols, like Ethernet, if they already exist. It doesn't try to invent the wheel. Any protocol that is created as part of the framework is defined in an RFC document. Maybe you haven't come across these yet. RFC means request for comments and is a very technical explanation of how the protocol or concept works. Some of these have been around for decades and are still used today. As these documents are available to everyone, any vendor can create hardware and software using these specifications. They'll all work together. Right now, we're looking at RFC 1122, which is the original description of the TCP IP model released way back in 1989. Now, let's take a look at the TCP IP model a little closer. Just like OSI, this model is made up of several layers. You can also see that there are 2 TCP IP models, which I have listed here as original and current. The original model had 4 layers and was defined in RFC 1122, which we looked at earlier. The revised model splits the bottom layer into 2 separate layers, which we'll talk about soon. The fantastic thing about the current version of the TCP IP model is that it lines up well with OSI. You can see that the OSI's session, presentation and application are all rolled into a single application layer. Personally, I prefer this. I like to think of this entire area as the application rather than trying to break it out like OSI does. I also personally think that we can break these models into 2 main areas. The top half is the application and their processes. In the application layer, we're talking about protocols like HTTP for web browsing, SMTP and IMAP for mail delivery, and FTP for file transfers. These applications create processes which listen on particular ports. That's the job of the transport layer, which uses the TCP and UDP protocols. We'll dig deeper into those very soon too. The bottom half focuses on getting the data from one host to the other. The network layer uses the Internet Protocol, or IP. You should be pretty familiar with this from the last 2 videos. The physical and data link layers move the data from device to device, that is, across switches, access points, routers, and other network equipment. Ethernet is a very common protocol here. And on this, we can see that the new version has broken the original link layer into the data link and physical layers. In the old days, there weren't very many different physical connection options. Now we have Ethernet, Wi-Fi, fiber optic cables, and so many more. While it originally did make a lot of sense to break up the physical connections from the data delivery, now we really have to. And that's why we now have 2 layers here instead of 1. Now into some more detail, starting at the top, the application layer. This layer defines the communications between applications onto hosts. This doesn't define how the applications work, of course. Instead, it describes on how the applications use the network. More examples here include SSH, Telnet, and RDP for remote administration. But we're just going to focus on HTTP as an example, because even if you don't know it, you're already familiar with it. We start with the applications. These are the web browser on the client side and the web server software on the server side. HTTP is the protocol that the applications use to communicate. If the browser wants to get a web page from the server, it will send an HTTP request. Just like OSI, the request passes down through the layers on one side and back up through the layers on the other side. Logically, one layer talks to the corresponding layer at the other side. The server will go through the same process to respond with the requested web page. The transport layer creates and maintains conversations between application processes on hosts. This is where TCP and UDP protocols come in. We haven't discussed these a whole lot yet, but put simply, they use port numbers to track sessions. Let's continue using HTTP as our example. The web server may have a process listening on port 80. When the client prepares its HTTP request, it will add a TCP header. We saw headers previously in the OSI video as well. The TCP header contains, among many other things, port 80 as the destination. It will also choose a port to send the request from. After the header has been added, we call this entire piece of data a segment. When the server responds, port 80.
Okay, I will share this with you in the course page, right? So I can summarize what I have taught you today. Actually, I wanted to do according to the lecture plan, we have to finish protocol, the OSI model, TCP IP protocol, analog, digital data signal. I could not finish that one, but some of these things, multiple access technologies, those things I have already discussed. So I am not, as it is following this one, this is the course plan I used in the previous year, but this year I may do some changes to that, not doing the same thing. So what we have to do now is now you have thought about what kind of questions I will ask in your assignments, MCQ test. So you don't have to worry about that. I will give some tutorials, so you can try this tutorial that will give some guidance to you what kind of questions will be asked. Now today, what I did is this book, mainly the data communication book. So I discussed what you have to refer is the chapter 1, chapter 2. You don't want to understand everything there, just guess the conceptual things there. And there we have done the OSI model, go through all these model, the layers, and the TCP/IP model. So mainly you have to understand these two. In addition to that, error detection and error correction. Error detection and error correction, and the data link control and the multiple access. right? So there are so many things are there. When you say the error detection and correction, I need your concepts only, right? Understand your concepts. When you say the error detection, what how the error detection is done and how the error correction is done, right? So what are the chapters you have to refer is the chapter 1, chapter 2, and the chapter 10 and chapter 10, 11 and 12, right? So any question you have?
So do we need to get a brief understanding in the what are the protocols and in detail about those protocols which were using separate layers?
You mean say
For
the
these
IP protocol?
modules?
You mean the, no, not necessary, deep.
Yeah, such kind of SMTP likewise.
No, not necessary. So,
Okay, sir.
so you have, when you see the module descriptor, you can see what are the things you have to done. You have to work according to that one. I will share the module descriptor with you. This one. Yeah. So this is the module descriptor. So these are the things we are expecting from this subject, right? These are the learning outcomes, right? In the assessments. So get some idea about what is in the module descriptor also. So what I taught you today is so many things are there. So it is not completely belongs to this module, but to understand this module, you have to understand the concept of all these things, right? Is it clear to your answer to your question?
Yeah.
Right. So your problem is there may be so many things are there, whether you have to understand all these things. That is not necessary, right? Understand the concept. We say the CSMA CD. What is CSMA CD, right? Just understand that concept, not all these detail. But again, I will discuss about this multiple access thing. So I am concerned about the multiple access required for the wireless network technologies, not all multiple access technologies, right? But to understand that one, you should know what is multiple access, why it is there, right? Is it clear what I taught you today?
Yes.
Yes, sir.
I don't use just some PowerPoint slides and just explain that one, right? I want to give you some good knowledge about this subject. So I think the way I'm teaching it should be very effective if you are really study this one, right? If somebody is doing the MSc here in the slate to get just MSc, that is something else. But take the maximum advantage of this subject, right? Okay, now for the next week, what you have to do, I give the tutorial. You can answer to the tutorial. You don't want to upload it, you can do by yourself, right? Just a question paper there. That is good, I think, no? That will be giving some guidance to you, right?
Yeah.
So your doubt is so many things we are learning, how we can answer to all these things. Don't worry about that, right? If you were in the class, if you listening to me, then you can easily get a good grade for this subject, right? Right. Okay, now you can put it to the chat box here, name and your student number. So I can, I'll put some materials to read to you. Mainly you need today from the book actually, right?